Today I'm going to take a typical calculus 1 question and make it more fun. Have a look. So we have the region y is equal to x squared and y is equal to 9 and x is equal to 0. So if we make a quick sketch, here is the parabola, and then we want y to 9 like this, and then we want x to be 0. So we're talking about this region here, and we want to rotate that about the y-axis, so it looks like this. And the question is asking us to find the volume. So you can make a quick sketch. You're going to get this. And I believe this is called the parabol. I'm not going to, anyways. I already have hard time to say the word parabola, so once you do a rotation. Anyways, what we are going to do is, I'm going to show you both the calculus 1 method and also the calculus 3 method. Calc 1, you just need one integral. Calc 3, you need 3 integrals. Let's have a look. So let's do the first one right here. Calculus 1, you have your solid here. And the idea is that we are going to add a bunch of disks, the volume of disk. So just make a horizontal cut, like so. And remember, the volume of a disk will technically just a really thin cylinder, right? So in general, it's just think about it as a cylinder. It's the circle, pi r squared formula, times the height. But this is so thin, so we'll call that thickness. So it's just pi r squared times thickness. Okay, for this right here, the r is going from here to here horizontally, and that will be the x value. And changes, so make sure you label that with a variable, because this x is different than that x, and so on. The thickness will be the small change in the y. So that's precisely the y. So the volume of a disk is x, the pi times x, square that, times dy. Okay, the volume is just going to be adding up all the small disks, and then that's it. So integrate the super version of the addition. Pi is pi, but x is not allowed in the y world. So if you look at the equation, it was y equals x squared, but now we have to change it to x equals square root of y. Technically a plus minus, but doesn't matter, just take the positive. So you have square root of y square dy. We are in the y world. It goes from 0 to 9. You can look at this, or you can look at this, doesn't matter. Alright, work that out, do that in your head or whatnot. You are going to get 81 pi over 2. Not so bad. How can we possibly use a triple integral to finish this? Let's have a look. So we are going to draw some pictures. Well, the picture is going to be what we have earlier. It's the same solid. So something like this. Here is my x-axis, and here is still my y-axis. Now, we're in Calc 3, so we need a z-axis as well. But where does the z-axis go? This is the positive x direction, positive y direction, the positive z direction. Does it go out from the board or go into the board? I don't know, I don't remember. I'm going to use my right hand rule. Positive x-axis, positive y-axis, positive z-axis. So hey, it goes out like this. So I'm going to kind of stick out the z-axis like so, and all that. Okay, now we need an equation, but the Calc 3 version, so we are going to have the 3 variable for this for this solid. What is it though? If you just look at the cross section horizontally like this, you see a bunch of circles, right? And if you project down the circle, you are on the xz plane. So in fact, this equation for this solid or for this surface, depends on how you look at it, is x squared plus z squared. Because that will generate a circle. And now, the y is going up like this, is y equal. So that's the equation for it. And you might be wondering, why not y squared is equal to x squared plus z squared? If you have y squared then you're actually going to get a cone, right? You'll get a cone because you can say that y squared is equal to r squared, where you look at the polar coordinates and you can see that y grows linearly to the radius. But anyways, I think this might be easier to remember. Yeah, just trust me too. Anyways, I did give you the explanation, so yeah. But what do we do next though? Well, triple integration time. And remember, I do have a video going over when you use triple integrals, you technically just put a dv at the end, but dv in the three-dimensional world is dx, dy, dz, or any order that you want, right? So it depends on what order that you would like to take. I am going to think about it. In fact, it doesn't really matter. I'm just going to go with the dx, dy, dz. I do have a video going over like how to kind of change all that, so you can watch that. If you have this dx, yeah, go to the equation, and it might be helpful if you look at this as an inequality. Y, right? If you write down x squared plus z squared, it's technically saying y is greater than or equal to that. Or perhaps a more classic way to do it is x squared plus z squared is less than or equal to y to a first power. Because y is the vertical axis in my picture, so that will be the inequality for that. I need to get x by itself. So I'll move this to the other side. X squared is less than or equal to y minus z squared. And then you see that x is in between of positive square root of y minus z squared and also the negative version of it. In fact, that's what we need for dx. So negative square root of y, that's y minus z squared up to positive square root of z minus y minus z squared. Next, I have y. It's actually not good to have dy next. I'm gonna switch it. Why? Because if you look at x and z, if I switch it, they cannot behave the same, right? So I'm going to actually have dz first before dy. Yeah. Okay. Anyways, if you have dz, now we took care of the x already, so you can just come here and just ignore that. So you're looking at x squared. So you're looking at z squared because we took care of the x. Is less than or equal to y, and then just isolate the z. Z is in between of positive square root of y and negative square root of y. So this and that. And finally, we are in the y world. If you look at the y, the very last integral for the limits here, it's always going to be a number and a number. Because remember, when you have a definite integral, at the end, it's going to be a number. So the very bottom number for y is 0, and then the very top number for y is going to be 9 because it says so. That's it. But I know the answer because we did it earlier. However, this is not good to compute because soon you will be integrating this thing square root of a constant minus z squared in the z world. Do you like trig substitution? Let me ask you that. If you don't, then continue watch the video. If you do, go ahead and use the trig substitution. So, how are we going to do it? I don't really want to do trig sub, right? The key is take this to the polar world and compute it. Okay, here we go. Triple integral. And what we are going to do is, I will keep dy all the way at the end, but I will have to change dx, dz into the polar. So for now, I will write this down for you guys. X, just take that to be like the usual coordinate system, like you change that the x component. X cosine theta take z to be r sine theta, because z goes like this. This is the total one, but anyways, here x squared plus z squared gives us r squared, and finally dx dz. Remember, when you're on the xz plane, it's kind of like looking at the shadow. It's like little rectangles and all that, and then you are changing dx dz into polar. That will be r dr d theta. So write that down with this r. Super important. If you forget the r, it's just as bad if you forget the chain rule, or maybe even worse, you forget the plus c after indefinite integral. So don't forget the r. I have so much passion with the r. Anyways, all right, so this is here. Now we have r going first. Be careful. It's not from 0 to 9. What's r? R is the distance from the origin to whatever that curve is, right? So that's r. Actually, no, that's too hard to draw it. I'm not going to do it. Let's just work with equations. Usually the first thing right here, just work with equations. Have a look. Earlier I told you guys this equation here should be x squared plus z squared is less than or equal to y. What's this? This is r squared. So r squared is less than or equal to y. Just do that. R is in between of square root of y and negative square root of y. Now, if you don't like the negative square root of y, it's okay, just use 0. If you don't allow r to be negative, that's fine. Just go from 0 to square root of y. It's okay. Because we can take care of the rest, that part with the d theta. Theta in that case will just be 0 to 2 pi. If you put negative square root of y here up to square root of y, you will go from 0 to pi only, right? Lastly, the y is 0 to 9, same thing. Yeah. Is this really much easier? In fact, once you compute this, it's kind of like what we did for the calculus 1 version, which is really cool, so have a look. Integrating this, we get 1/2 r squared, and then we go from 0 to square root of y. Put that here. It's just cancel, so we just get y. So this is 0 to 9, and then 0 to 2 pi, and 1/2. Let me still write it down. And then d theta dy. Okay. Have a look. I'm going to put all the terms with theta first, which is 0 to 2 pi, and then d theta, instead integrating 1. And then the rest, which is multiplying with integral from 0 to 9. We have the 1/2. But can I put a 1/2 in here? Yeah, 1/2. This 1/2 here. And then I will have the y here. And then the dy here. Does this look familiar? Yeah, it should. Calculus 1. Does this look... No, it looks like calculus 2 because of the trig substitution. But anyways, this right here, y squared over 2, plug in 9, so if you have t1 over 2, and 2 pi times that is just pi. So altogether, 81 pi over 2. And please do not ask me to do trig substitution for this.